So next up we have Neil Wetherall, the MD of Factorytalk.
Thank you very much. And thank you, Dirk, for making me feel old, because I look at some of those diagrams of plant designs and remember that, you know, in my late 20s I was designing plant by hand using pencil and paper for AstraZeneca or ICI as it was then. So, yeah, takes me back. As was said, I'm Neil Wetherall. I'm the Managing Director of Factorytalk. We're a software and services company, largely for the pharma industry, but not exclusively. And I want to talk to you today about this use case. And I say it's a practical use case. I regard this as a pragmatist's presentation, really. We're trying to see how we can apply the principles of Pharma 4.0, Validation 4.0, in a real-life use case, and see how far we can get, really, with that. So the use case in this case is an automated tablet packing line. It's designed by the Manufacturing Technology Centre, which is, their base is not far away in Coventry, but they also have a location in Liverpool, and that's where this case study is located. And Factorytalk have helped them with the design of this use case and implementing some of the technology. We also, you know, obviously part of this use case is about digital. It's about digitalisation. And so it's worth spending a few moments just thinking about what that really means to us in the pharma industry. You know, we know that in the pharma industry, you don't just sell the product. With the product, you have to have the records and the data. And you can't, you know, have one without the other. But much of that paper, as we all know, much of those records and that data is on paper. And so our kind of mission as Factorytalk is to try and help manufacturers get rid of that paper, get paper off the shop floor. That's what we spend our days doing, really. And then the advantage of that, obviously, I mean, I think you all know that, but, you know, just to call out a few things, you know, you can't visualize data easily if it's buried in paper and hidden away in your archive. You can't transfer that data from your pilot plant to your commercial operation, you know, if it's in the archive. Someone has to do a lot of work to transpose that data to make it useful later on in the product process. So, you know, there's real commercial value, there's real technological value, as well as just the practical thing about, you know, the cost of paper, the space required to manage paper, the people required to manage paper. When I used to manage a large packing plant, I had 2 permanent document officers and a big room full of paper just to manage my batch records. You know, and it's really difficult doing that and keeping track of it and getting the documents back and shipping them out. So there's a real benefit in moving away from paper. And of course, it's an enabler for Industry 4 or Pharma 4. So a little bit more about this use case. As I said, it's an automated tablet packing line. So it's not a full line, it's just the blistering element of that. But we've added some robots into it. It looks great, if nothing else. It looks interesting, and you know, and part of this digital manufacturing accelerator is to get people interested. I'll show you a little bit more about the location of it, which will make that make more sense in a minute. But yeah, you're using a robot system to place the tablets into the blister pockets on the line, and then we're heat sealing, we're printing online, but we've got vision systems all the way along that's doing the checking and the verification of the quality of the product during manufacture. And of course, digitalisation is built into all aspects of that. So as much as possible, we pull that data off the machine, put it into our manufacturing execution system and our quality dashboard, and make it visual for the operating staff as they're operating, but also you have that record as well that you can interrogate after the fact. So very simplistic diagram. You're forming cavities in the blister, you're adding the tablets into the blister, you're putting the lid on, cutting it, and then rejecting it. Fairly simple process. And then we've highlighted on this diagram some of the QC checks that we do on the line, and they're color-coded just to indicate whether they are critical or non-critical. So the green ones are the more critical checks that we need to capture. And you can see below the checks, what the method is for doing those checks. In the main, it's vision systems. We're also doing reconciliation live on the machine, and that's displayed live on the machine. So our aim is that we do automatic reconciliation between batches, so that brings down our changeover time and fits with the kind of rapid nature of changeovers that we're hoping for this machine. So because the green items are more critical, then they reside ultimately in our batch record. So our GMP batch record is in one system, and those critical checks are recorded in that. The other checks that are less critical, they go into our MES system. So we've delineated it like that. We didn't have to, but because this is a demonstrator, we're trying to demonstrate a range of technologies on the line. So we kind of had some choice about where we put the data and how we display that data. So we've chosen to split it like that, almost just to show the different technologies can also do, the recording and the displaying of the information on the line. If you were to buy this line, you might not choose those technologies, but you understand then that you've got some options. And so, just indicating which technologies we're using to record that data. So the batch line electronic record, as I say, that's keeping the records from those two green items. And then the manufacturing execution system, which is a platform called Tulip, and I'll talk some more about that. That's keeping those records, but it's also doing much more than that. It's doing a number of work instructions and processes and tasks, from material management through process orders all the way to reconciliation and line clearance. So I've mentioned, I think, no-code, but I'll certainly mention it now. No-code platforms or tools are a way of being able to build your own apps, applications on a platform without having to have any IT background. So you don't need to be a software designer or a coder to build apps on these platforms. Excuse me. The other thing about these platforms, and the EBR is the same, is they have IoT capability built in. So you can connect them easily to sensors on the line to pull that data in directly into the platform or the application and create a record. And you can also share that data with other systems, with databases. So that kind of plug-and-play idea of integration is there in these systems. The electronic batch record, that is the core GMP record for the production line. So that's validated system, whereas the MES doesn't necessarily need to be validated depending on how you're using it and what records you're keeping in it. But the EBR definitely is. And it's a kind of dedicated system designed to do exactly that, be an electronic batch record. But it also has that IoT capability. It also allows you to do a review by exception. So in your paper batch record, those of you familiar with manufacturing batch records, end of production, you get your 50, 100, 150 page document, and someone has got to go through every page of that and check that you can read all the entries, you can read all the signatures, the dates are all clear. With an electronic batch record, most of that work is taken away. The system does that. The system enters automatic date and time stamps. It puts an electronic signature on every entry, and it writes numbers and letters, legibly, automatically. So a lot of the review of documentation is eliminated. We reckon it saves about 50% of the time of a batch review per document by implementing EBR. So big gains. And the footer there shows you some of the detail of what you can keep in your GMP record using EBR. And the modern tools also allow you to have pictures, images, diagrams, videos in that record. So sometimes a record is just a record, tell me what happened. Sometimes it's got instructions about the setup of the equipment and the arrangement of things. And so having a video of how to set up a piece of equipment can be much more powerful than trying to describe that in words, especially with language. A video without any words can explain someone how to do that, in different languages. So there's those features as well, benefits of these kinds of systems. So I mentioned in manufacturing 4, Pharma 4. What do we mean by that? And I'm no Pharma 4 expert, but this is my interpretation really of how we've used this, how we've tried to apply it. So we've used this model. I think if you're members of ISPE, you will have seen this model before. So we've used this model just to illustrate that there's many strands to Pharma 4, and on this limited use case or example, we can't try and deal with everything, but what we have tried to address is listed there really, which is continuous monitoring where we can of critical parameters, and then simplified validation. So the continuous monitoring is checking the heat seal and the print quality, and the MES records and displays those continuous monitoring data. And we can also do challenge batches, so we can also have a work instruction within our MES that says introduce an incorrect tablet or a faulty tablet, or damage the blister and confirm that the controls and the checks actually work. So we can build that into the process of operation, either on a daily basis or periodically, whatever is desired. And then when it comes to validation 4.0, if you were taking that from first principles, you would start with the product, the process design of the product. But in this case, we don't really have a product. We're using dummy tablets. So we can't start from the principles of what's the process design and do the risk assessment on that. So what we've had to do is say, well, where does it start for us, and how do we manage that from a validation point of view? So, it starts with blister packing, that's the scope. And so what we've done is said, well, let's set a design envelope for this facility and this packing line, and have our validation bounded by that design envelope, and then confirm that we can operate within that design envelope. So what we started really with is a process map. So quite a detailed process map of everything that's going on in that manufacturing of that blister pack. Confirming the design envelope, and that every aspect of the design of the line as we are building it and designing it, complied with that design envelope. Then we do a process risk assessment. So this is quite a detailed risk assessment of not just the equipment items, but all of the tasks associated with making that product. So it's quite thorough. And from that, we identified controls that needed to be built into the line design and into the technology. And then we identified from that where we could apply that continuous monitoring. We have had to apply some traditional validation techniques to it. So, for instance, we've got a kind of optical system that's checking the various quality points in order to prove that we could use continuous verification, so continuous process monitoring. In the first instance, we've got to validate that piece of equipment using traditional techniques, but then we aim to show by monitoring the data over the life, the life cycle, that we are within the parameters that we originally set, and therefore in the future you could accept that equipment and just use continuous monitoring rather than doing the upfront validation. Is our aim. We'll see, you know, in due course whether that is borne out. So, a little bit more about the Digital Manufacturing Accelerator. So, as I said, it's designed by the Manufacturing Technology Centre. It's located in the Science Park in Liverpool, and that is that's the building there on that in this picture, and it's just next to the Catholic Cathedral in Liverpool. So, kind of in the centre of Liverpool, not in an industrial park somewhere, you know, in the heart of the city, and these windows around there, I think they're covered up with some film on them at the moment, but those windows are now open, and you can walk down the pavement here and see the blister line in operation with its technology from the roadside. So the public can see a working pharmaceutical blister packing line, you know, in their streets. And it's designed to be, as it says here, rapidly reconfigurable. So this blister line is just one use case. In that same facility, there's going to be an FMCG use case, so it's going to be a shampoo filling line as well. And at the moment, the blister line has got these robots and this technology on, but in a year's time or 2 years' time, it might have a different arrangement. So it's designed there that people from the industry can come along, look at the use case and say, yeah, that's great, but what if we swap that equipment for this equipment? How would it run then? Or what if we change the technology on it? That's the purpose of this, this accelerator, is to be a test bed, really, for different technologies. Alongside it, then, there's this digital factory environment, so like a virtual factory that, I mean, it says it's located in the Daresbury Computing Centre. Daresbury is a science park not far from Liverpool. It's happened to be where my office is, but it's just the location of some servers. There's nothing else there, really. But what that does is take some of the data from the line and do some processing of it, and then send that data back to the line, so that we can do some different scenarios using the data produced on the line. This is a little bit of a dig in a bit more to the line. So starting left to right, that's the flow of materials. What you can't see here is there's a trolley that locates here on the side of the line, and in that trolley are the change parts, excuse me, for 4 orders. So 4 tablet dispensers and 4 sets of change parts for the feed chute from the tablet dispenser and 2 trays that the robot picks out of. They locate in that trolley there, and you dock that trolley and then set the machine running, and the robot picks the tablet dispenser and the trays and locates them on the line and sets it up ready for production of the first order. And then after the first order has completed, then it returns those parts back to the trolley and picks the next tablet dispenser and change parts and locates them on the line. The next robot there, then, you can't really see that. I think that green bit is the top of it. And that's one of these multi-access robots, and that picks individual tablets out of the trays and puts them into the blister, the blisters on the blister strip, the formed blisters, and it knows when it drops one. So that's great, because that helps with our reconciliation. My only worry really with that was, what if it drops one in flight and that tablet bounces, and you know, and then we've got a rogue on the line? How are we ever going to find it? We don't know yet, really, if it's likely to do that. But the proof of the pudding will be when we start it up, which should be in the next 2 weeks. You then have this pick-and-place robot here, which is doing the change parts for sealing. And then you've got optical sensors all the way, vision systems, and you've got digital printing as well on here. And as I say, there are HMIs around the machine that are going to continuously show those critical parameters. And this is a little bit more about some of the technology that we have that's running the line. So there are a maintenance operations management system called Data Hone. There's a computerized maintenance management system called Ultimo, and then there's a QA dashboard that's been built on this tool called Dundas BI. They are not my priorities because they're not my products, but they're there. And some of you may be interested in those more than you might be interested in EBR. But what I'm interested in is the batch line product, the electronic batch record, and Tulip, which is the frontline operations or no-code platform, which we've implemented on this line. And those systems are all linked together via an OPC server, and that collects the data and then feeds it back out. So, we hadn't before connected data from Tulip to batch line. So that was a bit of a challenge for us, but it didn't take us very long to do that. And the guy who engineered that is not an IT person by background. He's a maintenance engineer, but he's learned how to do that pretty quickly, and it's working perfectly well. So, kind of shows what these modern technologies can do. You don't need necessarily all that wealth of background in IT and computing to configure these systems, which is what you're doing. You're not building and programming, you're just configuring. And what does it look like then? What's the output? So the MES, or the Tulip no-code platform, has a couple of examples of the screens that you see in there. This is an interactive work instruction. That's the kind of core of the products that of the applications that people build on these no-code platforms, certainly in the pharma industry that we're involved in. Lots of kind of digital work instructions. This one has got one little image, no videos, but many of them have got videos. But they're nicely laid out, nice and clear. You can have relatively few instructions on one page and then page through. It's a bit like paging through a PowerPoint, but it's got logic behind it, and you can interact with it, and it records the data from the execution. And then this one is the production execution dash within the MES, showing you what order it's on and the status of various items within the line. And then connecting to the virtual factory, we can do things like vary the temperature control and see what impact that has on the line and the quality of the line. And we can send the production schedule to the virtual factory and ask it to change the conditions and then send a new schedule back to the line, and that can happen automatically and change the production schedule. And then in the EBR, a couple of screenshots from what this looks like. This is the dashboard on the electronic batch record. Shows you a list of the orders that are running or planned to run. It also shows you all the exceptions. So whenever there's a variation from the perfect process, an exception is generated in the system, and a supervisor and a QA person have to go in and review and approve those. And that dashboard tells you how many you've got, at what severity level, and you can click through from that dashboard directly to that dialogue in that batch and review and approve that exception. So, lots of efficiencies come from these kinds of systems, and then that's an image of what the batch record looks like. So, this is an OSD example, not this actual blister line, but that's saying start time recording, the start and end time of processing, and then that's the date and timestamp. So, if you're interested in knowing more about these things, come to our stand and we can show you this in more detail. And then the QA dashboard, again, the look and feel is very similar to what you saw on the Tulip system, but that is some of the examples of the screens in the dashboard, which should tell you, all the status of the line that you might choose to look at. So, what can you get from the DMA? Well, you can see this for real, and no gowning necessary. It's a quick entrance into the facility and see this line with all its technology on. You can ask to have different runs. So, the first run will probably, be a single run, and then, make sure everything works. And then, we're aiming to do four batches in an hour, 15 minutes for a batch, and really fast changeover between batches. So that's the big thing that we're looking forward to seeing, how that runs, and does the automatic reconciliation work, and can we rely on that? We think we will be able to, but again, proof of the pudding will be when we run it. But you can specify your own demos. I'd like to see it run, a long run for 3 hours, and then 2 short runs, and then a long run or something. Whatever is important to the user to kind of show on this line. It's not GMP facility, but we are validating it. So we're doing that in order to demonstrate that it is validatable. This technology is validatable, hardware and software, and so we will have a validation report in a few weeks' time to demonstrate that capability is there. It's not just a show pony, really. But then it's a sandpit to trial other technology and other products and systems. So if someone came along and said, yeah, I like that, I like the line, but I would never use batch line, or I would never use Tulip, could you put another MES on it? Yeah, we can do that, and then run it, with that technology on. So that's one of the purposes of the line. And yes, as I say, if you want to know more, come and see me on the Factorytalk stand, and we can talk some more about it. Any questions?
Any questions for Neil?
Wonderful, thank you for the presentation. So many questions up until that last point you made about it's not GMP. So I had a lot of questions around validation and compliance. But the question I wanted to ask is, on one of the slides you talked about reconciliation, and then you mentioned rogue, right? So have you designed in the elimination of rogue tablets and other bits and pieces? Because the way I saw that slide, the reconciliation should pick up any deltas, right?
Yeah. So my worry, I guess, was, as I mentioned, what if the robot drops a tablet and we lose it? And the problem with it, when I say it's not GMP, if you come and visit it, you'll go, well, I wouldn't have that in my factory, and I wouldn't have that in one of mine either. And that's the downside of how we've had to build this. We bought a Chinese machine kind of that was ready built, and then we've modified it and adapted it. And all those screens and brackets and things are additive, whereas you would have designed it from scratch with all the flush fitting surfaces and no trapping points, and it's got hundreds of trapping points and stands where things get lost. So that's why it's not GMP. But in its operation, the technology is certainly validatable. But when I look at the travel of a tablet, I can't really work out a way of losing a tablet, and that's kind of my comfort really in the design of the line.
No, thank you for that. I mean, I've got experience of rogue tablets and how you find them in
Yes.
various places and stuff. On the electronic batch record side,
Yeah.
the data that you collect, is that represented in the EBR as primary, secondary, or tertiary data?
It's the primary data.
Okay.
Yeah.
And you're following Alcoa
Yes.
Plus? Okay,
Yeah.
cool.
Yeah.
Right.
Yeah. So that EBR tool is in the market now. It's used by lots of pharma companies. It's a pucker system. It's not a new system, that we've created for this solution. It's just the way we're using it, which is a little bit non-standard, and we're putting absolutely minimal data into that EBR, and we're using a Tulip just to kind of demonstrate that you could, really.
Hi, Neil. Thanks for the talk. I myself have been involved in the digital transformation with the company, and I thought I had covered some basic principles like being a top-down approach, merging IT and automation to make sure that we had a single team that could introduce that. But what I found out was that was much more difficult than I thought. It interacts, it interferes with every system you have in the company, right? From the quality, from the business, the enterprise management systems. And while I think this is absolutely great as demonstrators, I'm sure you have faced similar difficulties when translating these to practical cases. So in your experience, what are the key barriers in pharma industry to adopt this transformation in a more expedited manner?
I think you probably mentioned them. I think it's a strategic view. I think you have to go into this thinking strategically about the technology that you implement, understanding what it's for, why you're doing it. That's the most important thing. And you get situations where people see technology and they like the technology, and they get very fixated about implementing that technology, and they lose a little bit of how is that going to fit in the overall system of our company. So I always like to tie a technology project to the strategic objectives of the company or the site. If you can get that alignment and understand that, and you can do that in many different ways, but in essence that's what you should do, is have that clear strategic path of why we're implementing this technology or software and what it's going to give us. And then that helps you when you get decisions about clashing technology, which you do all the time. You know, we get all the time, well, and we see it on this line, we could do all of this in Tulip, but we've got batch line, so we want to do some of it in batch line. And you get that in companies, not just in, you know, examples like this case study. And you need to be able to be very clear on when are we going to use this software and when are we going to use this software and what's the reason for that. I think the second major thing is change management, and not change control, you know, not the technical change control of introducing a new piece of equipment, but change management that relates to people. So you can implement technology. That's usually relatively the easiest part of it, you know, implementing a software tool. But have you got the people that are going to run it? Can you train them? Can you release them from production long enough to train them? Have you got the people that are going to maintain that overall system using that technology? You might need some additional admin people. You know, have you thought about that? All of these aspects of change management are the things that, in my experience, stop us being successful with implementing digital transformation.
It's the same experience with me.